A modern merchant vessel is wired to trigger a high-decibel alarm at the first sign of a physical threat, a drop in oil pressure, smoke in the engine room, or a shallow depth reading. Yet the most persistent hazard on the bridge operates in complete silence. On a single 4-hour night watch, one officer is routinely required to simultaneously monitor electronic chart displays, ballast water management, planned maintenance logs, and live emissions data. In 1984, psychologist Craig Broad introduced the term technostress to describe the anxiety of early office computerization. Today, that concept has found its most extreme application in Maritime 4.0. This is the psychological strain that occurs when a human operator is forced to rapidly adapt to highly complex digital architecture without the necessary preparation, support, or interface design to process it. It does not register on a sensor array, but this cognitive overload is a measurable occupational hazard that completely bypasses traditional maritime warning systems. The industry rigorously drills crews for structural failures, fires, and collisions. In contrast, the mental bandwidth required to operate the vessel is routinely taken for granted. Fleet management often operates under a false automation paradox, the assumption that installing advanced software and remote diagnostic tools automatically reduces the workload for the crew. In reality, disparate data streams from vendor-specific platforms are poured on the end user. The officer must mentally bridge the gaps between systems lacking cohesive integration. Researchers at the World Maritime University have mapped this generalized burnout into a rigorous diagnostic framework, identifying 5 distinct dimensions of technostress. Pushing digital capabilities past the human limit of data absorption directly sabotages the safety and efficiency promises of fleet digitalization. The first dimension is techno-overload. This is the exhaustion of processing heavy volumes of uncoordinated data, alarms, readouts, and remote notifications across a single watch. A 2025 study confirmed this digital workload ranks among the highest daily stressors for officers. The second dimension is techno-complexity. The maritime sector has transitioned away from intuitive instruments to highly abstract digital interfaces that require deep systems knowledge. Operating these safely requires over a week of focused training, a standard operators rarely receive. This lack of training is compounded by frequent crew rotations. Officers step onto new vessels and face disparate interflight with minimal guidance. The result is a workforce trapped in a state of perpetually playing catch-up with the machinery they are legally responsible for operating safely. The third dimension is techno-invasion. Unlike a shore-based engineer, a seafarer lives inside the machine. They can never truly leave the office. Remote monitoring intrusions, emergency notifications, and non-critical system alerts bleed into off hours, shattering the boundary between active duty and decompression. Under the Maritime Labor Convention of 2006, seafarers are guaranteed strict minimum rest hours to ensure operational readiness. But shipboard technology actively erodes those protections, quietly threatening both the welfare of the crew and the legal compliance of the vessel. The fourth dimension is techno-uncertainty. Unstandardized interfaces and mid-voyage software reconfigurations create intense anxiety around executing daily procedures. Operators know that pressing the wrong input or misinterpreting a log during a port state control inspection carries immediate, severe regulatory consequences. A 2024 ISWAN survey shows 32.8% of seafarers fear criminalization from accidental rule breaches. This drives techno-insecurity, with 21.3% reconsidering their careers. Meanwhile, IMO discussions on autonomous ships signal future operations are designed without them. While shore-based industries rely heavily on change management to ease digital transitions, the practice remains completely unaddressed in the maritime sector. Penalizing professionals for unstandardized software errors while excluding them from the automation roadmap logically results in massive workforce attrition. Tech fatigue exists in corporate offices, but the strict parameters of maritime operations amplify the strain to a critical level. Physical isolation cuts seafarers off from the family, colleagues, and mental health services that land-based workers rely on to process daily stress. The traditional command and control hierarchy on board strongly discourages crew from openly expressing anxiety or admitting confusion about a new technological system. Simultaneously, massive external pressures like tightening MARPOL regulations and rigid decarbonization reporting are pushed directly to the vessel. Combining extreme physical isolation with immense global climate accountability creates a uniquely fragile operational environment. The global governing bodies overseeing maritime trade have yet to issue a structured response to this shift in cognitive load. Neither SOLAS, STCW, nor the Maritime Labor Convention explicitly categorize technostress as a defined occupational health risk. The STCW Manila Amendments introduced basic fatigue management, but those guidelines were drafted in 2010, well before total bridge integration became standard practice. The ISM code technically obliges shipowners to manage human factors, but cognitive strain entirely evades standard near-miss reporting structures. The current regulatory silence regarding high automation environments is an obvious gap waiting to be filled by incident statistics. The solution is not to halt digitalization. The industry must modernize. The necessary change is how deliberately that technology is integrated. Companies' safety management systems must be updated to require comprehensive, role-specific training prior to deployment, eliminating the cursory 30-minute walkthrough. Shipowners need to demand cohesive interface design from vendors and establish active crew feedback mechanisms during the procurement process. Remote monitoring must be structured with explicit boundary protections to prevent digital alerts from intruding upon legally mandated rest hours. Operators must have access to open-door policies and penalty-free shore-based mental health support to address digital anxiety. Human cognitive resilience has a strict limit. Outpacing that limit without structural support guarantees exhaustion, disengagement, and eventual error. Read the full peer-reviewed breakdown of the data and solutions at marineintelligenceweekly.com/articles.